So, good afternoon, welcome to DSC and also TET, SGT and SCA mathematics content classes. So, in this regard, I would like to start this chapter, statement chapter, the first chapter. Manu, good afternoon, welcome, and also Manikanta, thank you for Manikanta. Yes, definitely it will be continued live classes and share to your friends also. So, absolutely free classes. We have been conducting these classes for 2015. You can find even MSET 2022 classes also in this one. They are useful for even for your DSC preparation. But moreover, even now 10th class syllabus and 9th class syllabus, even 6th class syllabus prescribed for DSC will be completed during these live sessions. So, besides you can watch my previous videos also, they are available, freely available. So, this is absolutely free of cost. So, if you have any doubt, you can after completion of the session also, just in the live chat or in comment section also you comment it. In the next class definitely I will interact with you. Thank you Manikanta, thank you. So, definitely you asked me to start pedagogy classes also, definitely. So, I will go conduct pedagogy classes also in mathematics, right. So, okay, let us start today's chapter, that is statements. So, what is meant by the statement? It is very important. Statement. So, statement means actually a sentence, it is nothing but a sentence. Statement is nothing but a sentence which is either true, or false, but not both, at the same time, is called a statement. So, this is the concept of the statement. So, that means a statement either it is true or false itself only, but it is not both. Simultaneously it cannot be both. Either it may be true or false itself only, but not both. This is very important criteria. So, what are the examples? Because in the examination for 1 or 2 marks you may be asked the questions also in DSC. The 2 plus 3 is equal to something 5. 2 plus 3 is equal to 5 is the true statement. So, it's is we can say that absolutely directly true. So, for example, you consider like this, yes, definitely. So, for example, sum of the angles of a triangle, is 270 degrees. So, this is also second statement, this is the first statement, this is second statement, but sum of the angles of a triangle is not equal to 270. We know that it's absolutely, you can say that the statement is false. So, for example, if you consider like this, for example, x plus 2 is equal to 3. So, this is actually statement, but it is not a it is a mathematical statement. This is called open sentence, or we can discuss later actually. So, these are the examples for generally statements we can consider. Okay, next let us move to, so next one, second point. See, all statements all statements or sentences so can you imagine, but all sentences need not be statements. This is very important point, need not be statements. So that means we need to check whether we are able to give a counter example for the statement. So that means which are not statements. So now here let us write the examples here. So first example. So what is the first example? So what are you doing? So what are you doing means it's a question mark. So next, open the door, go to your classroom, or like that. So next, how beautiful it is. See, if you observe these three sentences, we cannot determine whether they are true or false. We can not determine. So that means what are you doing? This is the question tag, question. They have the question tag. Open the door. This is imperative sentences or commanding. Imperative sentences. Exclamatory. So they are what? Actually we can say that exclamatory. So these are not actually statements. So first example, second example, third example are not statements, simply they are sentences itself only. You remember one thing. So that means these are not statements. So that means how to recognize that it's not a statement? Only, for example, in the given sentence you have question tag, question or question mark, or command. So next, request or exclamation then easily we can say that not statements. Simply we can say that, very simple manner we can say that all declarative sentences are statements. You remember one thing, all declarative sentences. So question tag or request or command or question form or explanatory they are not statements, simply they are sentences. So very simple, one word we can say that all declarative sentences are statements, because we can, whether it is a true or false we can determine. So next, let us move to next concept. So next, third concept, let us move to the third concept. So next, truth value of statement. This is very important. Truth value of a statement. But means every statement has its own truth value. So that means truth values are actually here. So truth values, what are the truth values means? Truth values. So we can say true or false. These two are truth values. Generally this symbol is T, this symbol is F. You remember this one. Right? Clear? So that means now, so let us write one example here. Examples. Let us write examples. First example. See, 3 into 7 is equal to 15. So 3 into 7 cannot be equal to 15. So it's a false. So its root value is false. For example, so if you write like this, 5 plus 3 is equal to 8. Yes, it's a true statement. Sum of the angles of a triangle is 180 degrees. So this is also is what is the truth value of this statement? Yes, T. So now one more thing, remember all of you, generally the statements are denoted by small letters such as P statement, Q statement, R statement and S statement and so on. So generally we can say like this: P statement, this is Q statement, you can say R statement. Here P, the truth value of P is false, the truth value of Q is true, the truth value of statement R is true. I might have, actually you might have understood this one now. I hope it's very clear to you. Yes, Manikanta, yes, I know you are the subscriber of me and also you got TGT in mathematics in science school. Okay, all the best, right? So now let us move to fourth concept that is very important, open sentence. Already we had a discussion in the previous one. Open sentence. What do you mean by open sentence? Open sentence. Right. A sentence containing or consisting of at least one variable is called an open statement, or open sentence also we can say that, open sentence, right. So let us write the example now, examples. See, x plus 5 is equal to something 7. So this is a open sentence because it is consisting of one variable x. So generally we can write x plus y is equal to something 5, or x square plus 3x minus 5 is equal to 0. So these are all called open sentences. Example for the open sentences. So open sentences, actually you have one doubt whether they are the statements or not. So they are not statements. They are not statements. You remember this one. This is very important because we cannot determine the sentence is either true or false. We cannot determine. So that's why they are not statements. Simply we can call them open sentence. Open sentence means very simple. If a sentence is consisting of or containing of variables, so at least one variable means not only one variable, it may have more variables also, then we can say that open sentence. I hope it's very clear. Okay, now let us move to next concept. So now let us discuss the very important point, that is negation. That means negation of a statement. So that means indirectly we can say that denying of a statement. How to deny a statement? So that means actually this can be, any statement can be modified using not. So if the statement is modified by using not, that statement is called negation of the statement. If a statement is modified, that means rewritten, modify by using the word not, it's very important, not. So that means if a statement is modified by using the word not, then the new statement thus formed is called the negation of the given statement. The negation of given statement. So this is the actually negation of a statement. So that means, I repeat once again here, if a statement is modified by using the word not, then the new statement will be formed. So that new statement is called negation of given statement. For example, see, let us give the one example now here. Example, this is very important. Say the P statement 2 is a prime number. 2 is a prime number. So 2 is a prime number means, what is the negation of this statement? What is the negation of this statement? So negation of this statement is denoted by this symbol. This is called negation of P. This is a new statement obtained by actually modified using the word not. So now we need to write like this: 2 is not a prime number. Here we shall have one question in our mind. For example, if P is true, so what will be the truth value of negation of P? Simply you can say 2 is not a prime number means actually 2 is a basically prime number, but we modified the statement as 2 is not a prime number. Now what will happen for the truth value of the given statement? Now the new statement has been formed, negation P, that is 2 is not a prime number, but P's truth value is T, but whereas negation P means this becomes false. Suppose if the statement P is false, what will be the negation of P? Obviously it becomes true itself only. So now this we can state it as we can write it as a truth value. So let us write truth value, or truth table also we can write it. So let us write truth table for negation. So this is very important. So let us write truth table for negation, that is negation of P, right. So let us write the truth table for negation of P. So this is P, this is statement P, this is negation of P. For example, P is true, what is negation of P? It becomes false. Suppose if P is false, so what will be the truth value of negation P? Obviously it becomes true. I hope it is very clear to you. So next let us move to next concept. So next, see, let us move to next concept, that is negation of negation P. So negation of negation P, negation of negation P. So negation of negation P. So that is actually we can write negation of negation P. Let us see what do we get. So, this is equivalent value. What is the equivalent value? Let us try. So, let us try to write once again here the truth table for negation of negation P, right. Okay. So, now this is P, negation of P and negation of negation P. See, suppose we can write this is P, this is negation P, this will be the negation of negation P. So, this is true, this will be false. Again, negation of negation P is true. Next, this will be false. This, for example, if P is false, negation of P becomes true. Next, negation of negation P is false. Just observe the truth values of negation P. The truth values of negation P and P have the same. If you observe, see, observe here, both have the same truth values. That means P and negation P possess or have same truth values, same truth values. So, am I correct? Have you observed, all of you? Yes or no, you need to chart. Yes or no, you need to chart. So, then as the both the statements have the same truth values, they are said to be the equivalent statements. Equivalent statement means you can write P is equivalent to negation of negation P, or its converse also true. Negation of negation P is equal to, we can write P. I hope it is very clear to you, right? Yes or no, you need to chart. So, let us move to yet another. So, that means you can write like this also, P and negation of negation P, this is very important point, are equivalent statements, because they have the same truth value. Right, next concept, let us move to next concept, that is very important concept, 7th one. What do you mean by compound statement? That is very important. Compound statement. So, if you have any idea, you can chart through live session also. So, what is meant by compound statement? Do you have any idea? What is the compound statement? Right, compound statements. So, that means just think, for example, two or more statements are there. How do you combine them? Can we combine them? So, if you combine them, we get a new statement. Then what do we call them? So, how do we connect the two or more statements? Are there any connectors are there? So, how many such connectors are there, that we need to discuss. So, regarding to the, in the light of the compound statements. So, generally the compound statement means, so compound statement is obtained by connecting two or more statements. So, let us write now here, if two or more statements or, that means we can say simple statements, they are simple, first they are simple statements are combined by using the connectives, using the connectives like C, that is and is also connector, or if, then, next if and only if and only if, or it may be called as if only. So, these are called connectors. So, that means if two or more simple statements are combined, so combined by using the connectives like and, or, if, then, if and only if, then the new statement is called, then the new statement is called a compound statement, I hope it is very clear to you. So, that means actually here we have the connectors. What are the connectors? We have connectives. See the connectives. Let me write separately, connectives. So, first one is and, second one is or, third one is if, then, so fourth one is if and only if, okay. So, now let us discuss more about the different types of compound statements. They are very, very important. So, generally the connectives also called logic connectives also, logic connectives, symbol, and also let us write that, let us try to write symbol for compound statements also. So, that now we are going to discuss in the next part right now. So, now that is the under 8th, write down now here serial number, write down first, next logical connective, symbol, write down, this is very important, symbol, next compound statement, So, let us discuss one by one. Are you there? Yes. So, now the first, number 1, logical connective is and, symbol is actually this shape. So, generally we can call it as a cap also, cap shape. What is the compound statement? Name of this compound statement is conjunction. This is very important. Conjunction is also a compound statement, is by using the logical connective and, that will be found. So, conjunction is a compound statement formed by using the logical connective and. So, second one. So, that is R. The symbol is just like a cup. This is called disjunction. Disjunction. Sorry, not disjunction. Disjunction. So, third one is if and then statement. So, implies symbol, that is called implication, or conditional, this is called conditional. The statement is called conditional statement. So, next we have the fourth one, that is if and only if, biconditional or by implication, double implication also we can call, biconditional or double implication, I hope you might have got an idea on the logical connectives. What are the logical connectives? When we have and, or if and then, if and only if, and also symbol for this one is this, for and, for or, for if and then. And next compound statements we call conjunction, disjunction, implication or conditional, or biconditional, or double implication we can call. So now let us study one clearly about conjunction, what is meant by conjunction, what is meant by disjunction, and what is meant by implication or conditional or biconditional or double implication we are going to study in detailed manner. So next, first one write down, that is conjunction. So what is meant by the conjunction? If two are more simple statements are combined by the connective and the resulting compound statement is called conjunction. Right. So now, for example, let us write like this. Let P and Q be two simple statements. Then conjunction between these two is denoted by, so that means then conjunction is denoted by P and Q. How to read? This is P and Q. We need to read as P and Q. So now let's have a discussion on truth table for conjunction also. How to write the truth table? That's very important now. So next point is 10th point. Before writing the truth table, just you remember a one note. The conjunction of two statements true only when both the statements are true. So this is very important point. See, how to write the truth table for conjunction means the conjunction of two statements are said to be true only when both the statements are true only. When, for example, if P comma Q are the two simple statements, if P is true and Q is true, P and Q is also true. In all other cases, it's false itself only. So now means let us try to write actually truth table. Let us write truth table. This is very important. Truth table for conjunction. Actually here conjunction. 1 minute, let me write conjunction truth table. So now let us write the truth table. Right here, this is P, this is Q, P and Q and P also write down, no problem. So now write down P, this is Q, this is P and Q, this is Q and P write down. So my dear students, let us write, this is true, this is false, write down like this. Now let us write, for example, here P is true, Q is true. See, when both statements are true, this is also true, this is also true. For example, this is true, this is false, obviously false, this is also false. For example, if it is false, if it is true, this is also false, this is also false. Both are false, obviously false only, false, false. See, very clear here. When both are true, then only this is true, this will be true. Remaining all cases false itself only. That means the conjunction of two statements true only when both statements are true. So now what do you observe from this table? So if you observe these two compound statements, P and Q, Q and P, they have the same truth values. That's why we can write P and Q and Q and P are equivalent statements, we can write. They are equivalent statements. So equivalent. They are equivalent statements. I hope it's very clear to you. Okay, right? So next, let us move to the next one is, and before going to this one, we need to discuss even properties of conjunction also. Right. Next, properties of, as 11th point we shall discuss properties of conjunction. So first property. So what is the first property means? P and P is always P. Second, P and Q and P both are equivalent. Next, P and Q and R. This we can write P and Q and R. So you can have a one doubt how to verify. You can verify with the help of the truth tables itself only. So now it has the name. This is called idempotent law. Idempotent law. This is very important. Please remember. It obeys idempotent law. So this is called commutative law. So this is called actually associative law. Associative law. So actually these are the properties of conjunction. Conjunction follow idempotent law, commutative law, associative law. I hope it's very clear to you. So next, now let us move to next point, that is, so next compound statement, disjunction. So, what is meant by disjunction? So, if two are more simple statements are combined by the connective that is R, or the resulting compound statement is called disjunction. So, now note write down, my dear students, note write down. Let P and Q be two simple statements now the disjunction of P and Q denoted by the symbol is PRQ. So, now we shall have a discussion on the truth table of disjunction. So, disjunction of two statements is false whenever only both are false. Remaining all cases it is true only. So, that means you can write the truth table. So, now before writing the truth table, you remember the note. That note is very important. What is the note? The disjunction of two statements is false when both the statements are false. Only one case it is false, remaining cases is always true itself only. So, that means let us write a truth table for this one. Truth table, write truth table. So, let us write the truth table now. Right. So, now see, this is P, Q, PRQ, QRP, right. P, Q, PRQ, QRP. So, now this is true, this is true, this will be true, this will be true. Next, this is true, this is false, true only, true only. Suppose this is false, this is true, again true, true. If both are false, then only false, false, false. This is important point. Two statements are false when the both statements are false. When the both statements are false, the two statements are false itself only. Clear? So, now if you observe, these two statements are equivalent. So, simply we can write P or Q is equivalent Q or P. So, you remember this point. I hope it is very clear to you. So, next let us study the properties also here. The same properties follow like this. Right. Next let us go for conditional. So, now the properties also we shall discuss. Properties, write down properties. So, what is the first property? P or P is equal to P. This idempotent. P or Q is equal to Q or P. This is commutative. P or Q or R is equal to P or Q or R. So, this is idempotent, commutative, already we had a discussion. This is called associative property. So, very important is the next one. Next one is conditional is very important. In mathematics actually conditional plays vital role. So, while studying the geometry also, the most of the theorems will be based on conditional only. Right. So, let us move to next 14th concept. Right. Next let us move to next concept. Wait. So, this one is 14th one. Conditional or implication. Conditional statement, or we can say, or implication. See, if two or more statements are combined by the connective. What is the connective? By the connective, that is the logical connective. We generally call it as if then the resulting compound statement is called conditional or implication. Clear? Right. How to denote them? That is very important. So, now right, note write down. So, for example, let P and Q be two simple statements. The compound statement if P then Q is denoted by P implies Q, or simply you can write like P implies Q also, no problem. P implies Q. Right. So, this is very important. One or two bits may be asked from conditional also, right. It may be important for even JEE mains examination also, JEE advanced also. So, the mathematical reasoning, it comes under mathematical reasoning, and also it is very important for even electronics engineering also. In GATES you are going to study this logical connectives only. Right now, so we shall discuss the 15th point, that is, so let us study the truth table now. Note write down. So, P implies Q is always true, is always true, is always true, except, is always true except the case P is true and Q is false. Simply you remember one statement: a truth statement cannot imply the false statement. If P is true and Q is false, it is always false. Remaining all cases it is true. Simply this can be stated by means of a single sentences. So, very important point to be noted, very important. A truth statement, a true statement cannot imply a false statement. So, if a true statement imply the false statement, it is false only. So, that means when P is true and Q is false, it is false. The remaining all cases it will be true itself only. So, now we can write the table like this: truth table. Let us write truth table for conditional. This is important, truth table. So, let us write the truth table. So, now this is P, this is Q, this is P implies Q, this is Q implies P. Okay. So, now right, let us write this is P, Q. Now write down P implies Q, this is Q implies P. So, let us check whether P implies Q and Q implies P are equivalent the statements are not. It can be checked by means of the truth table also. So, my dear students, you see, for example, if true, this will be true, this will be true. For example, this is true, this is false. A truth statement cannot imply the false statement, so it is false. So, now the false statement can imply the truth statement. So, true. Here false statement can imply the false statement, true only. Only except this case, remaining all cases it is true itself only. Now, you see, Q implies P, true implies true, true, false implies true, true, but whereas true implies false, false only, true implies true, false implies false, true only. So, now if you observe the table, P implies Q, Q implies P do not have the same truth values. That is why P implies Q is not equal to Q implies P, because they are not equivalent statements. This is very important, you need to remember. And one more important point, see, this P implies Q means in words we can say like this, So, if P then Q we can read like this, or simply P implies Q we can read, or we can read it as P is sufficient for Q, P is sufficient for Q, or Q is necessary for P, Q is necessary for P. So, in 4 ways we can read this P implies Q. It is a mathematical way of representation, symbolical representation. In words we can read like this: if P then Q, or P implies Q, or P is sufficient for Q, or Q is necessary for P. So, it can be read in 4 ways, right. The next important point, let us move to discuss. Next important point is now, so 14th point. So, this is very important. In a conditional P implies Q, very important point, please note down all of you, it is very important point. P is called, it has a particular name, P is called hypothesis or given, that is also we can say hypothesis, P is called hypothesis. This is very important. So, you may be asked one of the questions from, if P implies Q, what do you call P? So, P is called hypothesis, whereas what do you call Q? So, Q is called here, that is actually conditional, or we can call hypothesis also, other name is there, that is actually antecedent, we can call it as antecedent, we can call it as antecedent. Here conditional is called consequent. I hope it is very clear to you. You remember this is actually P is called hypothesis or antecedent, Q is called conditional or consequent. So, next very important point, actually for the P implies Q, some more additional information we can have, that is very important for solving the problems. So, let us go for them, let us have a discussion on them. So, 15th point, let us have a 15th point. Here conditional is statement conditional. So, we know the conditional is P implies Q. So, this is the actually compound statement, conditional statement. So, now converse, what is the converse? Converse of this statement, converse. So, converse means actually if you interchange hypothesis and also this conclusion, if you interchange it, Q implies P, this is converse of the statement. Next, inverse. So, what is the inverse? So, inverse means Q implies P, actually this is the converse, converse means Q implies P. So, next inverse means negation P implies negation Q. Next, contrapositive, this is very important, contrapositive, this is very important. Contrapositive is negation Q implies negation P. This is nothing but converse of inverse, So, converse of inverse is called contrapositive. So, from the truth table we observe that, see, this contrapositive and conditional have the same So contrapositive and conditional both have the same truth values. So P implies Q is equal to negation Q implies negation P. Negation P implies negation Q, right. So in the next class we shall discuss about remaining one. So far we have discussed up to conditional implication. So once again watch the video, once again you go through the your any notes are there available. So try to solve the problems. If you have the doubt, just you can ask through live chat or live session also. Thank you, bye bye. So have a nice day.